All right, students, so now we're going to do 1.6. So if we go then here to classwork, go down to 1.6, antibody and antigen. We're going to be doing this assignment right here. Let's see. Okay, so again, when you do this assignment, you are always welcome to translate if you want to. You can write in any language you want. You can go to tools, translate document, and pick the language you want to translate into. That's fine. There's also space here for you to write in your home language, in my language, or the language that you speak, to translate the question and the answer that you find. So you can also, again, you can circle the words you don't know and just translate those if you want to challenge yourself a little bit more. So let's see what we have here. So it says your body has over 70 trillion cells. It's a lot of cells. Every cell has antigens. These are proteins that our immune system uses to identify cells. Our immune system distinguishes pathogens from our own cells by determining if the antigens are from your body or from a pathogen. And antigens that indicate that cells pertain to your body are called self-antigens. Antigens that indicate that cells do not pertain to your body are called non-self-antigens or exogenous antigens. So here, what the question is asking you is, what is the function of our immune system? So what is the purpose of the immune system? So our immune system, its job is to basically determine if the cells or the things that you have in your body are things that are, if the cells are your cells or the cells of something that is trying to make you sick. So, right, our immune system distinguishes pathogens from our own cells. What it does is basically it determines, is the cell in my body, is that something that is okay, something that is going to hurt me, or is it something that is my own cell so I can just leave it alone? But the function of the immune system is basically to find the things that that could cause me sick, that can make me sick. And the way that it does it is it looks at antigens. There are these proteins that are all of the cells have that we can use to figure out if the cells belong to us or not. So we're going to use the example of blood types. So each person has one of four main blood types. There are four different blood types. There's type A, type B, type AB, and type O. The difference between these blood types are in the presence or absence of protein molecules called antigens, again, on the surface of red blood cells. The antigen on your red blood cells are called self-antigens because your body naturally has these blood cells. If the cells have antigens that are different from your self-antigens, then your body will recognize them as harmful. Your immune system will eliminate cells that have what we call non-self-antigens, the ones that we do not have. So let's look at this a little bit. So how are the blood types different? Well, the blood types are different because they have, right? So here, if we're looking at the surface of the cell, so right, this is a cell A, cell B, cell AB, and cell O. On the surface, they have different little shapes. So if it's blood type A here, like this is it. So which antigen does it have? Does it have the A antigen or the B antigen? Well, blood type A has the A antigen. So what makes blood type A the reason that's called blood type A is because the people who have blood type A on the surface of the cell, they have this protein called the A antigen. Same with B. So blood type B has the B antigen. Blood type AB has both antigens on the surface. And blood type O has none of them. It doesn't have A or B. So the way that the blood types are different, right, is the presence or absence of these antigens on the surface of the cell. So let's go ahead and highlight this because this is our answer. So another word that you maybe have heard before is called antibodies. So antibodies are another type of protein, and they are circulating in your blood to interact with antigens. So non-self antigens are antigens that do not belong to your cells. So non-self antigens are chemicals or bacteria or viruses or pollen, things that are dangerous to your body. When the immune system identifies these non-self antigens, it creates antibodies that are specific to this non-self antigen. This antibody will bind to the cell with a non-self antigen and basically marks it to be eliminated by the immune system. And we'll look at this a little bit more. If this doesn't make sense, it's okay. But basically what happens is, right, when your immune system is going to look at the antigens on the surface of cells, and it's going to see if there are any non-self antigens, any antigens that do not belong to your body. And if there are antigens that do not belong to your body, it's going to create an antibody to eliminate it. So our body uses antibodies. These are little tags that our body uses to eliminate things that are dangerous. Okay, so let's actually look at this a little bit more. So here we have different types of blood. Again, you can always put the translation here if that's helpful for you, the translation of these science words. So let's label this here. So before, right, we saw that these are the antigens, antigen A and antigen B. So antigen A is going to be the one in this box. Right here, we have antigen A. There's an antigen A on blood type A, and there's an antigen A on blood type AB. Both of them have an antigen A. That's why both of them have an A in the name. So here we're going to write antigen A. So this one will go here. Then let's see, what is this one? This one here, this little kind of looks like a diamond or a square. Some people look at it differently, but that is the B antigen or antigen B. So we're going to put antigen B in this box here. That is what this blue one here is. So then let's look at here, what are the antibodies? So this antibody, these are two different kinds of antibodies. This is one, and this is the second one. The first, this red one is going to match up with this red antigen. So this antibody is specific for this antigen. So what you're going to do then is, okay, so this is going to be called antibody A because it connects to antigen A, right? It's going to, this one, if this antibody will fit on this spot here. Then we're going to do antibody B is the one that's going to fit on antigen B. So there we can attach it there. So let's look at this a little bit more down here. So first, so we want to look at each of these blood types and we want to answer these questions. So what self-antigens does each blood type have? What non-self antigens does the body want to eliminate? What antibodies will the body form against the non-self antigens? And what blood types can the body receive? So to look at this a little bit more, we're actually going to go here to this presentation that I made to look at this in a little bit more detail. So again, the self-antigens are the things that are on the surface of cells. So if we look at blood type A here, the self-antigen is the antigen it has here on the surface. So in this case, right, the antigen on its surface is antigen A. This is the antigen that it has. So the self-antigen for blood type A is antigen A. So this would be your answer for this part here. So for this first one, you can write antigen A in the box, or you can, in this case, right, I have this image here. Antigen A is the self-antigen, the antigen that blood type A has on the surface. What about blood type B? What antigen does blood type B have? Well, on the surface, it has antigen B. So I'm going to say that its self-antigen, the antigen that it has, is antigen B. So here I can write antigen B. What about blood type AB? Blood type AB, well, it has antigen A and it has antigen B. It has both of those on the surface. So its self-antigen are both of these. It has both antigen A and antigen B. Both. So I can write both, or I can write, so right, the options are antigen A, antigen B, both, or neither. So this is going to be both. Both antigen A and antigen B. What about blood type O? Blood type O, there are no antigens on its surface, right? It has a little stick, but it doesn't actually have the circle or the square. So in this case, it has none. There are no self-antigens that blood type O has. So there are none. There are no antigens that blood type O has on its surface. There's no self-antigen. Now we want to look, so again, right, we learned that, so a non-self antigens are antigens that our body does not have. Antigens that our body is like, whoa, you are not from here. You could cause me an illness, you can cause me a disease, so I'm going to eliminate you. I'm going to make an antibody to eliminate you because you could cause me an illness and I do not want to get sick. So let's see. If we look then, let's look here at so we know that, right? We knew that the self-antigen that blood type A has is antigen A. The non-self antigen, the one that it doesn't have, is antigen B. So since blood type A has antigen A, it will recognize, if it finds an antigen B on any cell, it's going to say, you are not from here, I'm going to eliminate you. So the non-self antigen, the antigen that it does not have, is antigen B. Blood type A does not have self-antigen B. So this is the like enemy almost. What about blood type B? Blood type B has, right? We know that its self-antigen is antigen B. The one that it does not have is going to be antigen A. It does not have antigen A. If it finds antigen A, blood type B is going to create antibodies to eliminate it. So it does not have the non-self antigen is antigen A. What about blood type AB? Blood type AB, it has two antigens. It has, if we look at the surface, it has both antigens. It has A and B, right? We found earlier that its self-antigens are both of these. So that means it does not have any non-self antigens. It's not missing anything, right? It has both of them. Both of those antigens are there. So it has no non-self antigens. There are no antigens that are missing. So here we're going to put none. There are no non-self antigens. And then what about blood type O? We know that blood type O has no antigens on its surface. So what we're going to say then, so it has no self-antigens. So that means that everything that it doesn't have is the enemy. So it means that antigen A and B, both of those antigens are the enemy because it doesn't have them. So both of these are called non-self antigens for blood type O. And if any cells have antigen A or B, they will be eliminated because these antigens are not present on the blood type O. It's going to say that these two guys are enemies. So here we're going to put both. Then the question is, okay, so now we know that, so what antibodies will it form? So what antibodies? So again, antibodies, so that you can also, again, if you want to just circle the answer here, you can also circle. What antibodies will the body form against the non-self antigens? Right, so in this case, right, we learned that for blood type A, the antigen that it does not have, the antigen that it wants to eliminate, the non-self antigen is antigen B. This is the guy that we do not have. This is the guy that we do not want him here because he is the enemy, right? It is not the one that we have, so he is the enemy. What we're going to do then is, right, so the non-self antigen that we have is antigen B. This is the one that we do not have. So what the body is going to do is it's going to create an antibody that will connect to this antigen B. It will create an antibody that's going to connect to it. And when the antibody and the antigen connect to each other, that will tell the body, hey, this cell, we need to eliminate it. We're going to remove it. We're going to kill it. We're going to destroy it. So which one of these antibodies is going to fit on this antigen, on this non-self antigen? Well, between these two, well, let's see. So we can actually crop this out a little bit, but let's see. So if we try to fit antibody A on top of right, they have to fit on each other. So let's see if we turn this around. This antibody and this antigen do not match, right? They do not fit with each other. So that means that I'm not going to form, if I'm blood type A, I'm not going to form antibody A because it's not going to eliminate my enemy. Actually, what it will do is this antibody A can actually fit on the actual blood type. We do not want to do that. If I'm blood type A and I create antibody A, this antibody is going to connect to me and it will tell my body, hey, this cell eliminated. But that's not good because this is my cell. These are the cells that I want. And I do not want my body to kill my own cells. So I'm not going to produce antibody A. What's the other option? Well, what about antibody B? Antibody B, does antibody B fit on antigen B? The answer is yes, right? These two are going to fit with each other. It's a little hard to see because they're pictures, but right, these two are going to fit with each other. This antibody B will fit on antigen B. And when these two things connect to each other, they will be eliminated. Like anything with antigen B will be eliminated. So the antibody that it's going to produce is going to be the antibody that fits with the non-self antigen. So that means that because antigen B is the non-self antigen, we're going to create antibody B to eliminate it. Antibody B. So blood type A is going to have antigen A, and it's going to create antibody B to eliminate anything that has antigen B. What about blood type B? So we can take a little shortcut this time, right? So we have antibodies. What antibody will it produce? Well, again, so blood type B, we know that it's the non-self antigen. The antigen that it does not have is antigen A. This is the one it doesn't have. And we want to eliminate the things that we do not have. So which one of these antibodies will fit on it? Well, antibody A will fit. So antibody A, right, will fit with this antigen A. It will, when it fits on it, right, it will eliminate it. So what that means is, right, and unfortunately, right, this antibody will not connect to B. It does not connect to B. So that means that it will be safe. It will not eliminate itself. So if we go back here, the antibody that this blood type produces is antibody A. What about blood type AB? Well, blood type AB, we learn, right? What is antibody A or blood type AB's non-self antigen? Well, it doesn't have any. It has no non-self antigens. It has both of the antigens already, so it's not missing anything. So because of that, right, we have no non-self antigens. So what does that mean for antibodies? Are we going to produce any antibodies? Well, let's see. What if we did? Let's say we did produce antibodies. What would happen? So if I'm blood type AB and I produce antibody A, well, what's going to happen? Well, that means this antibody A will actually connect to blood type AB. It will eliminate itself, right? Because this antigen A is also here. This antigen A is also here. It can connect to this blood type and eliminate it. We do not want that. We do not want to eliminate our own blood. So we are not going to produce antibody A. What if we produce antibody B? Well, the same thing, because blood type AB also has antigen B on it. And if it creates antibody B, it will also eliminate itself. And we don't want that. You do not want to eliminate your own cells. So what that means then is that blood type AB makes no antibodies. It will make no antibodies. No antibodies will be produced. So there are no antibodies that blood type AB has. None, or neither. You can say neither or none. None, neither. What about blood type O? Well, blood type O, what did we say blood type O's non-self antigens were? Well, it has, both of them are non-self antigens, right? Because it doesn't have any self antigens, right? There's no self antigens here. There's no self antigens on the surface. So that means everything is a non-self antigen. It's going to want to eliminate everything that it does not have. So let's see. That means that I'm going to want to, that means both of these are my non-self antigens, I want to remove both of them. So what that means, right? How do I remove both of them? Well, I need to have an antibody for each of them. So for antigen A, I'm going to have antibody A. For antigen B, I'm going to have antibody B. So I'm going to make two antibodies if I'm blood type O, because I want to eliminate both of these. Both of these are strangers. Both of them we do not know. We do not want to have them around. So it's going to make both antibody A and B. Great. So now let's think about this. So maybe you've gotten blood, you've taken blood before, or you have donated blood before. The question is, what blood types can each person receive then? So in order to do that, we need to think about what each of these have. So blood type A, what did we say? So blood type A, the antibody that blood type A has is antibody B, right? And blood type A is going to create antibody B to eliminate antigen B, because this is the thing that it does not have. It doesn't have antigen B, so it will create an antibody to eliminate all of the antigen Bs. So blood type A is going to have its antibody B. Where can this antibody B connect? Which one of these will it connect to? Well, antibody B will connect to anything that has antigen B on it. And which ones are the ones that have antigen B? Well, blood type B has antigen B, so blood type B will be eliminated. If somebody has blood type A and you try to give them blood type B blood, their body is going to say, no, you are not from here. I'm going to eliminate you. So because it has this antibody that's going to eliminate the antigen B, right? It's the antigen that it does not have. It's the antigen that is dangerous. So we are not going to be able to take blood type B. So this is not an option. You cannot, if you have blood type A, you cannot get blood type B because blood type A has an antibody for anything that has antigen B. What else has antigen B? Well, blood type AB also has antigen B, right? This antigen B is here. And again, so if blood type A sees this, it's like, antigen B, you are the enemy. I'm going to eliminate you. So it's going to also eliminate blood type AB. So if I have blood type A, I cannot get blood from A or from AB. Or sorry, I cannot get blood from B or from AB. Can I get blood from A? Is this antibody going to connect to blood type A? Well, no, right? It doesn't fit. Antibody B does not fit with antigen A. So we can accept blood type A. Blood type A is welcome to come. What about blood type O? Will this antibody connect to this blood type O? Well, no, right? Because there's nowhere for it to connect. Blood type O has no antigens. There's nowhere for antibody B to connect. So blood type A can accept blood type A and blood type O. It can accept those two things because those two blood types do not have antigen B. So it can receive A and O. You can also circle them. What about blood type B? So what we learned was that blood type B creates antibody A to eliminate antigen A, right? Because antigen A is the one that it does not have. So blood type B has its antibody A. So that means anything that has antigen A will be eliminated. So let's see, and which one of these have antigen A? Well, blood type A has antigen A and blood type AB has antigen A. Both of these have that antigen that does not belong to B. So what is the body going to do? It's going to eliminate those two. So if these two come around, it will say, no, you cannot come to my party. You have antigens that are dangerous. I'm going to remove you. Same with blood type AB, right? Since blood type AB also has that antigen B, we do not want him. What about blood type B? Does this antibody have anywhere where it can connect? No, it doesn't, right? Antibody A does not fit with antigen B, So that means that blood type B is okay. Same goes for O, right? Blood type O does not have antigen A, so it can be accepted. So here we're going to write B and O, right? Those are the two it can receive. How about blood type AB? So what did we learn about blood type AB? Blood type AB does not produce any antibodies. There are none. There are no antibodies. There are no antibodies. If there are no antibodies, that means that there's no way for it to eliminate other things, right? Blood type B was able to eliminate blood type A because it had an antibody that fits with the antigen on blood type A. This antibody will also fit on blood type AB. So that means that since there are no antibodies, there is no way to eliminate anybody else. There's no way for them to be eliminated. So what that means is that blood type AB will not reject anybody. All the blood types it can accept because it has no antibodies to destroy to eliminate them, to destroy them. So it can accept all blood types. So it's going to be A, B, AB, and O. So if you have blood type AB, you are very lucky. You can get blood from anybody. How about blood type O? So what did we say about blood type O? Blood type O, it's going to produce both antibodies. Both antibodies are going to be produced. So it has antibody A and antibody B. So if there's an antigen A or an antigen B, it will not be able to be there. It will be destroyed because it has both of the antibodies. So let's see. So which blood types have antigen A? Well, blood type A has antigen A, so that means we can't receive this because then this antibody A will destroy it. What about blood type B? Well, it has antibody B as well, so it will also destroy blood type B. What about for blood type AB? Well, blood type AB has both of the antigens, and there are two antibodies. Both of these will connect to blood type AB, so this also will not be accepted. AB will not be accepted. What about blood type O? Is there anywhere that these antibodies will fit? Well, no, because blood type O has no antigens. There's nowhere that these antibodies can connect. So that means that blood type O can come. So if you have blood type O, you can only receive more blood type O because you have both antibodies. You have antibodies against antigen A and antigen B. So that means that if you have blood type O, you can only receive blood type O. So what you're going to notice is that all of the blood types, so all the blood A, B, and O, all of them can accept blood type O. So that's why we sometimes will call blood type O. Blood type O is called the universal donor because any blood type can receive blood type O. And the reason, right, is because blood type O has no antigens. Blood type O has no antigens on the surface. So that means that there's no antibodies that exist that can eliminate blood type O. So that means it will accept everybody. So because it has no antigens, so no antibodies can eliminate blood type O. They all have to accept it. On the other hand, blood type AB, right? Blood type AB can receive all of the blood types. It can receive A, B, and O. So we sometimes call blood type AB the universal receiver. So blood type AB can receive blood from any blood type. And why? Well, as we saw before, right? So blood type AB, it has no antibodies. So it has no way to eliminate anything else. If you don't have any antibodies, you cannot destroy anything else, right? Antibodies are what our body uses to destroy other things that are dangerous. So it can receive blood from any blood type because it has no antibodies to eliminate any other blood type. Since it has no antibodies to eliminate other blood types, that means that it is a universal receiver. It can get blood from anybody. And that here, students, is the summary of what we saw.